Greetings and hello. Um, Today I have a technical overview to share about how we can use Hashicorp Vault with its SSH secret engine to be able to issue signed SSH certificates for Linux systems authentication. Let me make with a screen share here. Alright, so this is the SSH secrets engine that I'm talking about. You'll notice that there's two options here, the signed SSH certificates and then the one-time SSH passwords. We're going to be diving into this top one. The bottom one here needs like an agent that runs on the target machine. And so I don't want to dive into that one just now. They have a tutorial attached here when you sign on or click on through there to the signed SSH certificates that kind of walks you through the various intricacies about it. We're actually going to be getting into a lab a little bit later where I'll configure Vault with two SSH CAs, one for host key signing and one for user or client key signing. Then we'll configure a couple of servers to use that Vault server for authentication. And issue some signed SSH certificates to do a little bit of authentication testing back and forth in that lab environment. Finally, towards the end of it, we're actually going to explore some Vault policy examples that we can use to affect the permissions that a particular user could request whenever doing the certificate key signing. Let's see here. So this tutorial that Hashicorp Vault has posted is very good. They do a lot of the setup, like Vault secrets enable SSH client signer is something we'll do with Terraform. I'm going back over to the repo. This demo Vault SSH secrets engine repo will have the content here shared. Terraform under here is our Terraform module that'll be used to configure Vault. And in this main.tf, this Vault mount named SSH client signer, this is basically the same thing in Terraform that the tutorial over here is doing on this line right here. And then this line right here, creating the CA backend, is this next section down here. So we're pretty much with Terraform doing the exact same thing or almost the exact same thing as you see in this tutorial. It just makes it a little easier for me to stand everything up and execute the demo in an expected manner without having to copy paste all of the CLI commands to set up Vault. So I still recommend kind of reading through all of this and definitely playing with Vault to see how all of it works together. It didn't make any sense to me until I'd actually configured it and started using it, and it was like, oh, several aha moments along the way there. Let's see here. This docs here, the Vault provider is the provider that we're going to be using to configure Vault with Terraform. Let's see here. And then auth methods are something we'll get into. Let me switch back over here. Actually, I'm a little out of sync. In the demo, at the very bottom here, this user paths authentication method that we're defining, we're going to use that to kind of act like we're logging in as a user would. And Vault provides several authentication methods for that. Let me scroll down here. This is just the default page, but auth and methods, app role, Ali Cloud, AWS, Azure, like this whole list right here. This username and password is the one we're enabling, but like you could link it to LDAP so that using Active Directory or FreeIPA or Red Hat IDM or Open Directory, you log in against LDAP, and whenever you do, you get assigned a particular policy, and that policy can dictate what you can do with signed SSH certificates. So that's why it all kind of works a little bit better with Vault in this place instead of like we had seen last week or previously on one of my other demos where I covered the introduction to SSH CA signed certificates for authentication, but we were using purely OpenSSH tooling to do it. It was all a much lower level, no service provider involved kind of thing. So let's see here. All right, the demonstration itself. Back up here. There we go. So this terminal here, I've got 3 screens broken out. I'm not connected to anything yet. And I don't have anything created yet. So just a moment here. All right. First thing we're going to do is make sure that we have our demo network created here. All right, it already exists, and we're going to create our client and target machines. These are just system D containers like you've seen me use before. I'm going to make sure that I have the version of Vault that I want. All right. I'm going to start this. All these commands are in that demo doc in the repo. We're going to start the Vault container, and we're going to start it in dev mode. It's important to note that this is in dev mode because we're telling it to use this as the root token, so it's something I can easily retype just for testing purposes. We're not going to do any TLS or SSL encryption on it, and when this goes away, the data goes away. It's all stored in memory, so this is kind of an ephemeral setup that I'm doing here. So if you're following along, you definitely want to know that this vanishes anytime you restart it, and you'd have to rerun the Vault config parts. Okay, yeah, it looks like it did set up properly. It loaded my root token, gave us an unseal key. Clear that out. We won't actually need any of that data right there. I just wanted to make sure Vault loaded correctly. Now I'm going to log into the client machine on these first 2 terminals. And I'm going to log into the target machine on the bottom one here. There we go. Good. Now I'd mentioned these are system D containers, right? It's got a couple of processes running in here, including SSHD. Same thing here. They're all based on the same container. It's an Alma Linux 10 container. We already have some environment variables exported here, so Vault. There we go. So that's why that's already kind of working. This is skipping the TLS checks. Let's see here. Moving back up to our actual commands here. Where are we at? All right. So going over to the Vault console, the first thing we're going to do is actually go ahead and get Vault configured. This is on my actual workstation, so I'm having to export these values. And my Vault container publishes 8200 right here on my local machine, so I can access Vault directly from my box. Let's check Vault status. It should pretty much get the same thing. Initialize, seal. All right, good. Now let's go ahead and clone our Git repo. This is the repo that the demo's in. I'm going to cd down into that Terraform module. And the first thing we'll do is a Terraform init. That's going to get our providers and modules and everything all downloaded. All right, that's ready. And now we'll do a Terraform plan. We can see we're going to be adding 11 things. We can kind of scroll through here and see what all is being added. We've got our user pass backend being created for authentication. We've got our SSH client signer, SSH host signer, client role, another client role, another client role, and then a host role. Then our client CA and our host CA. Admin backend. And the host backend role. Alright, so in order to apply that to Vault, we'll just use this Terraform apply command. Whoop, missed a quote there. There we go. Alright. Now that should pretty much configure Vault. What I'm going to do now is I'm going to send curl commands directly to the Vault server, and it should show us the public keys. Right? This is for the client CA. Public key is available. Again, I'm passing in secure because we don't have any SSL certificates in play. We're not actually listening on HTTPS, but if you were, you would need this in order to do that download. So I guess it's a little extraneous in this one. We can use the Vault CLI to read these values as well for both the host and the client CA, right? And then back on our test boxes in the lab, we can also read from these as well. Nice. Good. Everybody can see them. All right. So now, before we move on, I want to go ahead and add some users to that user and pass authentication backend. And I'm going to pin each of these users to a specific policy, the policies that we created. There's the first one. Second one. Third one. And fourth one. There we go. All right, now let's see here. All right, let's go take a look at the Vault web UI now. Just going to show you what we have. I'm going to log in with token. What was our root token? There it is, root token. All right, so we can go into secret engines and we'll be able to see here's our SSH client signer and the host signer. Under access, we have the user pass backend here and the users that I created. Each one of these is linked directly to a particular generated policy. So we'll be able to see how the policies affect Vault's ability to work with this backend. If you descend like into the SSH client signer here, it should take you to the role. Yeah, so you can have multiple roles on one CA. So like this one would be for admins. Maybe you've got another one for regular users. Maybe you have one for service users. And then these roles, let me open this up a little more. They tell us like the defaults for, oh, this is the actual key signing. Backing up to the role. There we go. They show us the defaults for like allowed domains, allowed extensions, and then the default extensions. So if I'm requesting key signing, I can request all of these extensions in my key signing, but by default I'll only get permit P2I. Allow bare domains. So they're very similar to like the PKI roles that Vault has. Yeah. Backing up here, the host signer has the same kind of thing. You can sign, paste the public key here, give it valid principals, and it will output the signed certificate. And then the role is back here one to see, max, TTL. These are very long because they're for host certificates. Yeah. Back up here. And back to our terminals. Right. Users created. All right. So first thing we're going to do is let's configure the client and target machines to trust the user signing CA. I'm just going to go ahead and configure both the target and the client, and we're going to use them kind of interchangeably as just SSH servers to and from. We're basically grabbing that same key we read earlier, the public key from the client signer, and we're writing it to this etc SSH trusted SSH CA keys file. And if I cat the contents of that file, it should just be an SSH key basically. Yeah. There we go. And that's the public key of the SSH client signer CA in Vault. Now I'm going to use a here doc to extend the SSHD configuration. This is adding the trusted user CA keys path to point to the file we just created, and I'm also disabling password authentication. I'm doing that so that when we do the testing, instead of failing and popping up and asking for a password whenever the key fails, it'll just deny authentication. Same thing like if the certificate expires, rather than popping up saying, well, your cert expired, do you want to give a password? The login will just fail, making things a little simpler. Going to do the same thing on the target machine down here. And then I'll restart SSHD on both of those machines just to apply that configuration. Now up here, as the root user on the client machine, I'm going to go ahead and create SSH keys, ED25519 keys without a passphrase. Do the same thing down here on the target machine. And now I'm going to sudo to this admin user that I have, and we'll create users for it too. There we go. And now I'm going to populate the known host file on both of these users. And we're curling to get the public key from the host signer for this. You can see with this cert authority for the .local domains, type of key, and then the public key. We'll do the same thing on the target machine. Back out to root. This is a per user setting. All right. All good. Now, on the client machine, I'm going to unset my vault token because it's the root token right now. The echo. There we go. And when I unset it, I'm going to log back in as the host admin. And that was, there we go. Once I've logged in as the host admin, let's see here, I will sign my host key with the Vault CLI. Vault write, I'm just asking it to give the signed key back. This is the CA path that I'm writing to. The cert type I'm requesting. Valid principals should be my FQDN or host name. And then I'm passing in the public key, the host key, from this machine. And then we're going to output that information to this path here. That'll generate our signed cert. I'm going to do the same thing on the client machine down here. And then we can actually show the contents of that certificate. Boom. Type, it's host certificate, the public key, signing CA, the key ID. This is neat, right? Because it's Vault, because I had logged in with a user from the user pass backend, and that user was the host admin, all of that information goes into this key ID. It's kind of neat for being able to track it backwards. And Vault automatically implements the serial, so I'd be able to track this back in Vault. My principals are set, and it looks good. Same thing down here, principal set, signing information. Oh, I didn't log back out and log back in with the host admin here, so you can see this was done with the root token or a token. So you'd have to track down what token this was in order to figure out who signed the certificate. Let's see here. Now we'll go ahead and make sure that ownership and mode are set properly on those. I'm going to extend the SSHD configuration to include that host certificate. And then we'll restart SSHD. All right. Now, there we go. So if I, as the TKC admin user, target.local, this should fail. Yeah. Now, I'm going to unset my vault token, and I'm going to log in with my admin user. I'm going to try again. Why not type in that password right? What? Oh, I see what's happening here. I have the wrong export. It's telling me that it's defaulting to the 127.0.0.1, but since I'm on the container, I can use the actual vault.local username. I just missed one of my copy pastes. There we go. Ah. Now I can look up my vault token. You can see that I have this role and I'm not the root token. I am this user pass admin user. And now I'm going to attempt to sign my public key. And that would be this public key right here that I'm attempting to sign. And now I believe this should fail because we're not allowed to request one of these. Let's find out. Yeah. So that had to do with the policy over here. Where I'm not allowing this extensions to come through. We're allowing public key, TTL, and valid principals, but I'm not allowing passing extensions, so it's not letting it go through. What we can do to work around that is we'll just take that extensions bit out of the request. Okay, both are not working, and we sign our key. And now we're working. And we can see down here the information got passed through as far as that key ID and everything, user admin, vault, user pass. This PAM systemd thing is not related to what we're testing. This has to do with because we're operating inside of a container. You can actually get that error to go away by editing PAMD system auth and then password auth to get that out of the way. And I should also be able to log in as root. There we go. All right. Now we can look at the cert that we actually signed and created there. You can see it's a lot of the same information, shows our validity, the principals that I can log in as. It's all there. Now you can specify that key like this, where you do -identity path to your private key, -identity path to the signed public certificate. But since we use the default name for our keys, I was able to log in just directly. If you don't use the default name, you can specify them like this and it'll go right through. And you can also load them up into an SSH agent, right? Paste that in here. I can show that there's no keys in it. And then if I add my private key, it's going to see that cert and it's going to grab them both and stuff them in the agent. See, we get them both here. Good stuff. And we can still SSH. Good stuff. Let's see. One thing to note when you are using these SSH agents like this, if I were to come in here and let me just sign another, there it is, I'll sign it, and then I'm going to go back and add it again. Now let me list that. Oh, I have two. What's going on? Because both of these are in the agent, if these had different permissions, or one was expired and one was not, it would try one and it would use those permissions, and if it didn't work, then it would try the next. But where I ran into issues with this was when I was just testing, and the certificate I was using had root allowed, and then I issued a certificate without root principal allowed and went to SSH and it let me in as root. Wait a minute, what happened here? And it's specifically because of this right here. So if you want to dump a particular key, you can do it just the one key with -D and then the path to the private key. And you can do a D and it'll get rid of them all. So that's how to work around that particular thing. Let's see here. All right. We were also going to play with that restricted policy, because the policy for the restricted policy says that we deny these parameters explicitly and we only allow TKC admin. So someone with this policy attached would not be able to authenticate as root. They could only request for the TKC admin principal. Alright, let me sudo TKC admin again. I'm going to do my exports. And I'm going to log in as some user, which has that restricted policy. Oop. Typoed my password. No, we didn't typo it. So I'm going to sign with a failed payload first. I'm asking for a root principal. Can't do it. So I go back and I just ask for it with TKC admin instead. It lets me in. And I'll just type it. Root at target.local should fail. Yep. Invalid principal. But TKC admin should go right through. Yep. All right. Let me show you what that cert looks like. Just the one principal. All right. Now I've dropped Sarut and elevated back to TKC admin again, and I'm going to show the super policy, right? You've seen the first one where it didn't let us change the extensions. This super policy, where did it go? Is it this one? There it is, client role. It allows us to any role, not just the admin role. And then it has capabilities to create an update. And then we didn't give any constraints, like as far as what is allowed. So pretty much allowing everything. Come back in here. Log in. Vault token lookup to show you that I've got that policy. Roll all. And now this should succeed. And it would let us log in as root or TKC admin. And it should add permit port forwarding to our certificate. Remember the first one, whenever we did that, it failed because we didn't allow it by the policy. There we go. And it actually added it on there. So while the original token would let me SSH across and get a TTY and I could, interact on a console, it would not have allowed port forwarding. SSHD would have seen this as part of the certificate and been like, no. But with this new certificate, since I do have permit port forwarding on there, it would have allowed it. The SSHD subsystem would have seen that and been like, okay, sure, port forward away, why not? Now you can see that we can connect to the target machine as both root and as TKC admin. Yes, we can. All right, that covers pretty much how all of this works with Vault. We're going to do a little bit more of a demo with low TTL certificate signing, but I want to touch on the Hashicorp Vault and what they don't really say about key revocation lists or KRL management. Pretty much in all of the testing we've done here, you've not heard me talk about revoking keys or key revocation lists at all, and that's because in the forums and pretty much anything I've found that discusses Vault and KRLs comes back to Hashicorp saying that you want to just use appropriately low TTLs on the signed keys so that they expire before you ever even have to worry about revocation. Now, what does that look like, right? We're watching our target down here. Let me exit TKC admin account and then elevate back into it. Export our exports, and now I'm going to log in as that. Let's see here. Was it the some user account? There we go. And I'm going to assign a 1 minute certificate here. Like, what can you do in 1 minute? Not much. I can get logged into the box, maybe. But I'll show you here. Validity 2353, 2354. So now, if I go ahead and SSH to TKC admin on the target machine, it's going to let me in. I'm logged in. I'm on the target machine. Things are running. Now I'm waiting for that date to expire, or that validity. $23.54.44. 14 more seconds. Now I can still, at this time, if I hurry, log into this machine. Yep. And I'm still in there on the first one. Now, I think it should have expired by now. Yeah, so if I try to SSH again, I should be refused. And we can see down here, certificate invalid, expired, but I'm still on that machine up here, right? I've logged in. You can see me logged in there. And as long as I don't disconnect, I don't need to re-sign my certificate. So I can sign my certificate with this little 30-second, 1-minute validity time, get logged into my destination and start my work, and then let that certificate expire and continue my work. Doing it that way makes certain that there's no way that I have to worry about like revoking that key. It's going to be revoked before expired rather, before I've even finished my work. And at the same time, like my Vault login, right? Let me back out of here. Vault token. Look up. Yeah. This login is for like 767 hours, just because it's some of the defaults that I've got there. So this token is going to be good for a very long time. I wouldn't have to log back into Vault again until May with this particular setup. Now, you probably would want to put some limitations on that, maybe daily Vault logins or something. But that's just to say that once you log into Vault, you can re-sign a new 1-minute certificate with a quick scriptlet, and you're good to go for a minute again. So you don't have to log in again. You don't have to do anything. You just have to make sure your Vault token is good, and you're able to sign, and then sign your client, log into your SSH target, off and running you go. Certificate expires. Keep finishing your work, and whenever you log out of that box, if you need to log into another one to continue your work, you just run the script to sign your key real quick, and off you go again. And in doing it that way with those very minimal TTLs, 1 minute, 30 seconds, just long enough to get logged into your destination, you don't have to worry about KRLs anymore. So you don't have to worry about it. I'm sure there could be some use case, but it's a lot less dramatic if you don't manage them, if every cert expires within a minute. So that covered pretty much everything I wanted to cover on this topic. Gives us a few examples of how Vault can be used to help manage Linux SSH authentication. Adding SSL certificates to Vault, of course, is something you would definitely want to do if you're moving this out into production. And there's some further exploration opportunities around Vault integration with those external authentication sources, such as an LDAP provider like Active Directory or FreeIPA, as well as exploring how TLS certificates affect this particular setup. All right, let's call it a day there. Thanks again, and I hope you've enjoyed the content.